Yeah, thank you very much. People are still a bit tired maybe after the lunch break. I always get these slots after the lunch break, and I hope it will be interesting for you. So we'll talk about open source vulnerability management. And if you read the synopsis in the agenda, it's about software development and cloud environments mostly. Where what we don't touch will be like on-premise classical infrastructure. So it will be mainly software development and cloud. Let me start. Who am I? Stefan Fleckenstein. I work for Mayborn Wolf. Mayborn Wolf is a German software consultancy and software development company. We build software, individual software for clients in Germany, lots of well-known, some not so well-known companies in Germany and their customers. And we do this with a full-stack approach. We have data, we have mobile applications, we have web applications, we have IoT, we have smart devices. We start doing a lot of AI. And there are a lot of cybersecurity is needed these days as well. And so I'm head of the cybersecurity department at Mayborn Wolf. So we don't provide cybersecurity for our own company, but for our customers, where we do consultancy about cybersecurity or implement security-related software. What are my passions? I have three main passions which are relevant today here. So this is, I did a lot of software development in my life, more than 25 years. In different consultancies, I started as a software developer, software architect, managed software projects, stuff like this. Then the last 6 years, I've done mostly cybersecurity. It started in an internal role at Mayborn Wolf, where we started to do a lot of cybersecurity there and passed the ISO 27001 certification, which I was responsible for. And there I really developed a passion for cybersecurity, did a lot there, which then led to founding the department for customers 4 years ago, in the middle of the pandemic it was. And the third passion is open source. I think the open source stuff is really great. There are lots of tools and it's a lot of fun. Work with open source communities, because you give something and you get a lot back, and this I really like. And because I'm not doing software development for money anymore in my company, I do it as an open source developer these days. And so I was 2 years the maintainer of Defect Dojo. That's an open source vulnerability management with an OWASP flagship project. And then roughly 2 years ago, started my own project, SecObserve, which we will see later a little bit more. All right, what we'll do in the next roughly an hour. So we start with some motivation. Why are we here? Why are we listening to this talk? Talk a bit about how do we do security testing in software development, and then see how does this open source approach work there, and ask the question, well, does it really work? To give you some confidence there. So let me start with 4 cases from the last years. I think a lot of you heard about Log4Shell. This was, I think, December 2021, short before Christmas, where Log4j, which is one of the most popular Java libraries, which is used for logging, became known that attacker can load and execute malicious code via the JNDI interface, and there was immediately a wide range exploitation of this. So there was Bitcoin mining, there were ransomware attacks, and everyone was running around and not having a nice Christmas time, but running around, are we affected? Is the software affected that we build? Is the software affected that we use? Are systems affected that we use, like the locking system of the doors maybe? Nobody knew. And this is really bad in a way. Come to this later. MoveIt last year. MoveIt is a tool that does file transfer, is often used for sensitive data like HR systems. And there was an SQL injection in the software. And there's a blog which describes how that happened. And it's a really classical SQL injections where you think these days, can this really happen anymore? And yes, it can. And so there were ransom attacks like on the BBC, the British Airways, the Nova Scotia Bank, and others, where a lot of data was given to ransomware attackers. Not good as well. Detectable? Yes. I found an interesting case in the research. There were 4 airports in Colombia and Peru which had 3 terabytes of data in an S3 bucket at Amazon, which was publicly available. Everyone who knew it, who found it, could access it. And there were personal data of employees in there, but other sensitive data about layout of the airports, where are fuel lines and stuff like this in there was completely public. Luckily, it was discovered by security researchers. If you search for it, you can find it. And it was not known that it was actually exploited, but imagine what could have happened there for these airports. 4th case from this year, quite new. A Microsoft employee published credentials in a Git repository. I think it was on GitHub, that granted privileged access to an internal Azure container registry where they have internally, or should have been internally, I mean, it's in the cloud, but nobody should have access, where they had their containers for several of their software, and it was available. I think no exploitation here as well, but what if some attacker uploads a malicious container of Teams or something like this? Not good as well, and all of these cases are avoidable, and we come to these later. How does actually testing work? In general, we have 4 ways how we test software for security. We can do code reviews. So for every merge request, we do often code reviews anyway for software quality, that it adheres to the architecture, that it works, stuff like that. Or when we do pair programming, the 2 pair programmers do it against themselves. And so we should look for possible security vulnerabilities as well there. But there's a good chance to actually miss some problems because it's cumbersome. You have to look at a lot of things. There is a guide from OWASP, secure review guide, secure code review guide. It has more than 200 pages. I don't know who writes so long documents, and pretty sure more or less nobody reads these long documents. So it is important to do it, to look at the code, but yeah, you will miss things. Sorry. Then there are functional tests. There are stuff like authorization, authentication, input validation. That can really be tested very well with unit tests, integration tests. We do system tests on larger levels, load tests to see how it behaves. So this is really good to do, but it doesn't show that you have vulnerabilities. It just shows what you have implemented. You have implemented the right way, which is good. Penetration tests. In our company, we see that our customers are not doing them really regularly. It's typical for an initial release, not for lots of systems we build. The customer says, no, we don't really need it. So it's more the critical systems. And then, yeah, when we go into production the first time, when there are larger changes, but it's not regularly. And it's good, again, outside view of the system, you find things, but some things still you might not find. And so the final piece in the puzzle is the vulnerability management, which typically runs in the CI/CD pipeline, or you run it regularly every night or stuff like that, and where tools are used to cover different perspectives, which we will see later in this talk. And I think if you have all these 4 things together, then you have a really good chance to build a secure product. And it gets more and more important, not only because the software we build, the software we are using gets attacked, but there are a lot of regulations now. We are heard about from the guys from Audi here before about regulations. They have a tier 2. We have the Cyber Resilience Act in the European Union soon. We have NIS2, and we see that lots of areas are now covered by different regulations, and they all say something about vulnerabilities, that you shouldn't ship your products with known vulnerabilities. So how does it work? An overview for the start. We have a developer. He writes source code, develops things, commits them and pushes it into a source code repository. A CI/CD pipeline runs, does tests, builds the software, deploys the software, and as part of that, there should be vulnerability scanners running to see if they find anything in the code, in the libraries, and other stuff there. They get imported into a vulnerability management tool so that people can actually have a look at it, like the developer or other stakeholders, and can see, oh, well, there is stuff in there and we should do something about it. And optionally, you could push it into an issue tracker. So when you use an issue tracker like Jira, in GitLab, GitHub, or anything else, push it in there so it's part of your product backlog to say, okay, these things need to be cared for. And yeah, this goes back to the developer. And then you have a workflow where you find things, where you can detect things and care for things. So we have 5 steps that I think are really important, and we start with number 1, very important, avoid vulnerabilities, because every vulnerability that's not in the system will not be found and must not be cared for, because you will see later, every vulnerability requires some work that need to be done, and we don't want to do that. So security by design, really important to start it very early in the process, to have your, don't know a proper English term for it. In German it's Schutzbedarfsanalyse. I couldn't really find a proper English word, so I use protection needs, where you say, what kind of data do I have in my system and what will be the impact if you breach confidentiality, integrity, or availability? What will really happen? Is it just a minor thing that you can easily mitigate, or is it an existential threat to the company maybe if this data gets lost or is not available again? So then you know the impact from a threat modeling, threat analysis. You find out, where is my system, where can it be attacked, how what kind of attackers could there be, and what is the probability of, is it really easy because there might things that a script kiddie can do, or do we really need to get prepared if some state actors might attack us? And so with risks, so you can have risks from impact and probability, and so you know your risks, then you can find your security requirements and the measures that need to be done to build a secure system. They can be part of the architecture, how you build things, use OIDC for authentication, stuff like this. They can be in user stories, like I have a user story, write an authorization, role-based with these requirements, or they can be in the definition of done, saying, yeah, every service must have authentication and every service must be TLS encrypted and stuff like this. So then all the requirements are there, and you can start building a secure system. Oh, and then so next, automated page management. Keep your things updated. You have libraries, you have Docker images. Keep them really updated regularly. And there are tools for it, like the Renovate bot or the Depender bot, to automate this. They look at your package JSON, poetry log, stuff like this in your Docker files and say, there's a new version of this library, generate a merge or push request for it, and then you can deal with it. And this is really important to do it really regularly, because then you are used doing it. And if there is something where you have to react very fast, like with Log4Shell, then you're really used to do it. You have the process. It's not that you haven't changed anything the last 3 months and have problems doing it. And do the major changes as well. They are a bit hard often. Then you have something that's in version 4 and now it gets to version 5. That's not just accepting the push request, it's much more work. Still often really helpful, because if in an old version there is a vulnerability detected and then you have to go to version 5 in a hurry and there's a lot of work involved, have a problem again. Yeah, keep it simple, as few libraries as possible, as many libraries as necessary. There are some things you shouldn't build yourself, like authentication. You should always have libraries for this. People have made it better than you can, but not everything needs a library. Some things might be easier to do it yourself, and then you know they are fine. And use small base images, as small as possible, like Alpine, distroless stuff. When you have a normal Debian-based image, they often contain a lot of vulnerable things that might not be relevant for you, but you have to look at it. So this helps. And last in this list, security champions. This is a concept, if you don't know it, where you have one person in your team who really cares about security, who knows what needs to be done and cares that things get done concerning cybersecurity. The tests are done, that all the processes have been followed. They must not do everything themselves, but they really care about and see and have a look at it, that there are some things in the product backlog. They push the product owner not to only do functional things, but care for these things as well. Really helpful. And training of programmers really help, that they avoid many pitfalls they could do from the beginning just because they know how to do things. And I think with these 4 things, you will already build a very good and secure systems from the start. So what needs to be checked? So yeah, we have the vulnerabilities in dependencies like Docker images, your NPM, Maven, other stuff. You have the cloud configuration in your cloud. Hopefully you have it all as infrastructure as code. So this can be checked. The vulnerabilities that might be in the application code you should know, and if you have any secrets in the source code repository. So I want to introduce some names here. So this all checking of dependencies is often called SCA, Software Composition Analysis. We will see this on later slides, this abbreviation. We have SAS, what is that? Static Application Security Testing. These are tools that basically read the source code and do a code review. They have a lot of rules there and can detect things then in the code that something is missing. Or dynamic application security testing, where the system really runs and there are test cases, often automatically generated, that run to see if it's secure from this point of view. And yeah, Log4Shell was a good example for the first one, because there are always in your dependencies, there are always things you will find, and Log4Shell was a good example for this, to say you should know about them and react as quick as possible, or as quick as necessary, depending on the risk. The airport example of the Colombian and Peruvian airports was a good thing for cloud configurations. If you use infrastructure as code, and there are some dynamic tools as well we can see later, then you would find there's an open S3 bucket. You will find that and say this should be closed. This can be easily detected, actually. Yeah, vulnerabilities in the source code, the MoveIt example, and SQL injection is really easy to find. So this SAS tools, they find this stuff very easily typically, and so would be completely avoidable to have this in the source code. And secrets, yeah, the container registry, the guy who accidentally checked something into the Git repository. This stuff happens, seen all the times, and so there are tools to detect this, and that you don't have anything in there. And even if you say, well, it's my company Git repository, is it that important? But you don't know how many people have access to this, and maybe they read something, leave the company, and then can exploit it. So even if in your own internal repositories, there should nothing be in there what is really a secret. So step 2, use a curated list of vulnerability scanners. We've done this. We used a lot of tool in our company and have a list. This is mainly the list of things that really work. So for to check libraries, there's dependency check. For mainly Maven, there's dependency tracker tool that works on SBOMs with its own user interface. Scribe and Trivia are these typical kind of tools that go over your package JSON and other stuff, and the Docker containers, look at the Docker container, see what's in there, and where are newer versions, and where do you have any CVEs or other known vulnerabilities in there. SAST is often specific for the programming language. So Bandit checks Python code, ESLint, JavaScript, TypeScript, finds bugs Java. There are tools for Go and others as well. Typically, you will find an open source tool for every programming language, or most of them. SemGrep is a tool that there's an open source version and a paid version, but the open source version is quite good. That can work with a lot of programming languages and has then special rule sets for different kind of environments. SAST, there are some tools to check stuff like Terraform, your Docker files, Docker Compose files, Helm charts like Chekhov, Kix, or Trivi again. Trivi we see more and more often for different things. For secrets, we use Git leaks a lot, although there are other tools as well. Dynamic OWASP-ZAP, lots of you will know as an open source tool that can do a lot of things there, partially manually, but partially they can do stuff automated in a pipeline as well. Some basic and some more elaborated checks. There's a tool, Dr. Header, I think it's written by Santander initially, that checks, it's in the name, HTTP headers, if they are set correctly. I think this is a science on its own, how to set these headers, and there are some good guides for it, for example, from OWASP, and they check, you can have your own rules, there's a standard set of rules, and it says, yeah, you should have this, and maybe you should have different settings. And Cryptolyzer checks the whole TLS encryption of your connections and says what it found there, and we use it in a way that we check it against the BSI norm, or you could do the NIST norm as well, and see are there things that violate this current regulations there. And then there are some other tools that are not really in that works a bit different. Prowler, Azure Defender, they really need access for your infrastructure for the cloud. They need a cloud access, and then have a lot of rules so they can be used. If you don't use infrastructure as code, you could still use these kind of tools, and there's someone working currently. Trivi can work in a Kubernetes cluster as well to check all the configuration there, and then you get the data out via Prometheus and access this via an API. This is a method as well. So there are a lot of tools, and there are more around as well that you could really use. That's great. Problem. You have to integrate when you, this can be really tedious integrating these different scanners because they're all installed differently. Sometimes they have just the Docker image, sometimes they have a script how to install it, sometimes it's a binary you download from GitHub. it's all different, and when you call them, they have completely different parameters. So you have to check every manual to see what parameters you can set, how you set it. It's not very much fun. So what we did together with the SecObserve tool to have a repository with GitLab CI templates and GitHub Actions. They provide uniform methods for launching the tools, a unified set of parameters there, and so then it gets really easy to try different tools to see the outcome. And so there's a huge Docker image with it where you can use things, and it gets regularly updated, typically once a month. So then you have the latest features, bug fixes in these tools available as well. How does it look like? This is part of a GitLab pipeline. You include a template in GitLab for the vulnerability scanner that runs in the stage test, and you need only a few lines, because here it says, yeah, extend the vulnerability scanner template you have just included, and use a configuration that I show in a moment, and that's done. That's all you need to do in a GitLab pipeline. And for GitHub, with the GitHub Actions, the pre-made actions, is basically the same idea, the same complexity to do this. You could have templates if you just have one or two of the tools. You could have single templates as well. And then in the configuration file looks, for example, like this. This is a YAML file where you have a section for each scan you want to do. You say which kind of scanner do you want to use, like Bandit or Trivy image. Trivy can scan container images, or Gradle files, or package log, or stuff like this. Then would be great. Trivy file system. You say where should it run, what's the target, and the report name. So it writes the report as a Sarif, as a JSON format, a special kind of JSON format, and so they write then a file, and this file then is part as an artifact. You could download it and have a look at it, but then there's an importer section that says, yeah, do an upload to a SecObserve instance where you then can have a look at it as well. And so this is really easy to be done, not much effort, and then you get results very soon and can start to work on it. Yeah, that's the thing. All the scanners, they write JSON files, and you could just run the scanners, and I've seen people just running the scanners, and you can break your build, if the pipeline, to say if it finds something that's higher or critical, then stop everything. I'm always not sure if it's a really good idea if you have a critical bug fix to do, and then something gets detected and the pipeline says, no, I don't do it anymore. And yeah, looking at these JSON files and have a look what's happening is not much fun. And nobody does it. So then they get, I've seen customers, they set up these pipelines and then never look at it again anymore. And this is not what makes sense. So the files should get imported in an open source vulnerability management tool like SecObserve, for example, which I will show. And that's really easy because they are API wrappers. So this is as part of the GitLab templates, GitHub Actions, but there are other tools that have other vulnerability management tools that have API wrappers as well. So, final step, and it's the longest step then, assessment and remediation. So we have imported it into our system. Now we can start working on it. What kind of vulnerability management systems are out there? There are, I think, basically really these three. There's Dependency Track, which is an OWASP flagship project. It's very mature, started 7 years ago. A good single-page application, really easy to use, but this is really specialized. It reads SBOM files in cyclin-dx and does SCA, software composition analysis, and checks for licenses. And they could do license checks in there, with your own rules. It's a very good tool, but it's very specialized. It does one thing. This one thing it does really good. There's Defect Dojo, very mature as well, an OWASP flagship project as well. This has a really complex user interface where I would say this is more suited for security specialists. You would not have programmers and other people working with it. There you have a special security team that really cares for things. Then it might be a good idea to use it. I was a maintainer of this for 2 years and know its strength and some weaknesses as well, but it's a good tool if you can use it, and it has hundreds of scanners that you can integrate there, and there are a lot of stuff that cares for on-prem and other stuff like Burp and all the things, lots of commercial scanners. There's a lot of support in there. If you do more than software development in cloud environments, you might want to have a look at this. But we will now talk about SecObserve, because basically a tool that we've written in my company where I'm responsible for. But it's open source, so there are no limitations. We don't use the beta versions. Then you can download. Everything is open source there. It's pretty new, started last year. A modern, clean, single-page application, we'll see. But it has this focus on software development, maintenance of cloud-based software systems. So the list of scanners we saw are basically what is supported. Plus everything that can write the SARIF format, because this is lots of SAS scanners write SARIF. This is the one JSON format for SAS that is supported by GitHub as well. And so lots of scanners use this. They can import it, and if you have your vulnerabilities in an SBOM, you can import them as well from lots of other tools. What will you get? So what we've seen is, there are some vulnerability scanners that import their vulnerabilities in there. There's an OpenID Connect authentication, so you can have your own users, but you can have your OIDC server like Entra ID, Google or others connect to it that you have your users in there, and with a role-based authorization model behind it, so everyone sees or can do only what they're allowed to do and see. We have some APSS scores. This is a score about the probability that things got exploited already. This can be added so that you get an idea of the risk. Is this just a vulnerability, or does it get really exploited already? And then some more integration. VEX files are a way to express vulnerability status. There you could say, oh, I know there's a vulnerability, but the vendor has said that's not relevant because it's a false positive or it cannot be exploited. These files can be written and imported. You can export stuff to Excel CSV to get it in other systems. We don't have the code in the system, so there are code links to several code repositories, and you can generate issues, not in DevOps at the moment, but GitHub, GitLab, Jira, Cloud, you can export the issues surrounded, and they get then tracked there as well. So if someone changes in the vulnerability, the issue gets changed as well. Notifications, if something happens, you have a new vulnerability, that's really critical. You can send a message to Teams, Slack, or via email. And then some information links to NVD for GitHub advisories. Open Source Insights is a helpful tool where you can see more information. So you get a very good infrastructure around it that really makes things easy. So let's have a look at it, how it really looks. This is how the system looks. We start with the dashboard where we see some graphs about severities, about status, what's going on, how the timeline is. Then we have products. I have here demo product, TROOPERS24, which has, you can already see some open observations. We call it observations here in the tool because they are detected. Some things have been detected and imported. But if there are really vulnerabilities, we don't know yet. It's just something that has been observed for the moment. And then you get a list of different things that coming from different scanners. And so you have everything in one list, and you don't care if it's SaaS, DAS, secret, infrastructure, open source code. It's all in one list, and the idea is you have a similar look and feel for every tool. So you don't hear people who just use this don't care about different scanners that have generated the observations. It's always a similar look, sometimes with more or less information. That really depends then on the scanner, what the scanner actually gets. We always have a severity and a status. Severity is critical, high, medium, low, and informational. Status we'll see in a moment. We have a description that comes from the scanner. The scanner has a recommendation. We have it here. Sorry, we have a vulnerability information. So for dependency, we see the CVE, and we could directly look at it at the CVE database of the NVD, which currently is more or less helpful. Like CVS scores and stuff like that, the EPSS score. We see where it's coming from. It's the cryptography 4105. We could get more information about this. We see where it's coming from. So how is it integrated in the system? So there's a library called encrypted model fields that uses this library. And this is then often helpful to do your research about it. We see a log if things changes, some meta information, references. So you get a lot of information when you start to look at things. You can really look at a lot of information around it and some extracts of the original reports. Like here, this coming from a SBOM. You can here see the relevant extracts of this SBOM as well if you want to see a bit more of it. When we look at others, for example, something coming from a Docker file, it says, ensure that the user for the container has been created. If we have a code snippet in the report, then we show it here as well. Unfortunately, the Chekhov parser then gives us the whole Docker file. It says, yeah, ensure that the user for the container has been created. Again, we see the origins, and when we have a source code repository specified, then we have to link to the source code as well, where it then goes with the line numbers. It's not properly configured here at the moment. Or for example, yeah, the hard-coded SQL injections, this is something, this is not a real application, this is I really put it in the source code, something like a query that is hard-coded, and this is roughly really what happens with the MoveIt tool. And so to see, yeah, they are found easily, and you can have a look at it and you can change it. So really see a lot of things here, and then can start to actually work on it. And we see we have a lot of information. It looks similar. As I said, we could export it. To different formats, the metrics, and we could do manual imports as well. The idea is you get your scans in a pipeline, but you can import stuff as well from files and partially from APIs. Like if you use dependency track for SCA, you could have an API call to that. You can work with branches and versions, not configured here, but you can say I have my main branch, dev branch, or different versions where I have the data separated. So there are lots of ways how to work with the system. All right, now you have it all there. That's good for a start. But now you have to do an assessment of it. So you want to eliminate undesired results. You can have false positives, things that get detected where you say, nah, that's not true. You could have things where you say, no, I'm not affected. It's there, but I know the reason there's a library, but how I use it, this thing cannot be, this vulnerability cannot be exploited. Or sometimes they report stuff that's just not security related. And so you can eliminate, you can change the configuration of the scanner. Say the SAS scanner should not check test directories because we don't care about them. So you could do this in the configuration of the scanner. You can do an assessment per observation, or you can make a rule-based assessment, which I will show. You can. So then you have the list that are really relevant. You could accept risks. You can say, okay, I know the risks. I have my threat model with the risks. And so I just say, yes, I know it's there, and I know it might be exploitable, but I accept the risks, and it's documented that I did it and who did it. And then you start to fix vulnerabilities, the remaining things you might want to fix. And then with the next scan, so you fix things, you check it in, and with the next scan, the tool will says, oh yeah, I didn't find it in the next report anymore, so it's set to resolved, and it's not in the lists anymore. So you don't have to resolve things there as well. The scanner sees it, and with the next import, it automatically is resolved and out of the way when you have done your work. So we don't have to care about that. Let me show a few things how to do it. So here a manual assessment, our hard-coded SQL expression. We could say, we could change the severity or the status. I could say, well, no, it's not affected, or I say I put it in review. We have to look at it. Here it's pretty clear actually what happens. And so I would say I wouldn't change the status, but I say that's not medium, that's critical. And then it changes the status. If you see that it's done, you have a log entry who actually said it, which user, when it was done, stuff like that. So it's all audible. And so you can do manual assessments. You can remove it as well when you see that was wrong. We have stuff in there. I marked some. So here it's something where we have a false positive because Python Django has some functions that don't look like functions, or where we have a false positive. It says if superuser a function on attribute, it looks, because it doesn't have the parentheses at the end, but it actually is really a function. And so there's a rule about it saying every time you see something like this title with a regular expression and coming from the same grep parser, say that's a false positive as a rule. So you set this rule once, and so, or you could do it with the title, with the origin. You have several attributes where you can set rules on and say, how does it change the status or the severity when this happens? So you can automate things here as well. And there would be the VEX files. If you have, people would supply you a VEX file saying, yeah, this is not relevant, then this could be imported as well. So you really get a way how to deal with things to make the list smaller I would always say start with critical and high. And if you haven't done it at the beginning, you will have long lists. But you can get them really smaller quite fast, and then have a reasonable amount that where you can really work, and you know what's happening. And you can accept the risk if you say that's too much for me at the moment. You have visibility, and if your management asks or something happens, you have an idea what's happening. So does it work? So they're all open source scanners. Are they any good? Do we know? So we had a master thesis in our company 2 years ago, I think, where we checked vulnerability scanners against our security experts in the projects and checked the false positives. Do they get a lot of small false positive? And it was less than I expected. So the false positives that they give are, so they don't give a lot of them. Security, the scanning of the secrets, that's always a bit tricky. That the scanners work with lots of different reg access. They find a bit too much, but it's always worth looking at it. And the second one is the quality. Is the quality good, especially the severity? And what we found is all of the critical vulnerabilities the tools found, our security experts said, yeah, we really think that's critical and it should be done. With the high, it's not 100%, but still 91% of the high vulnerabilities the tools found, our guys said, yeah. And it's a bit less for medium and low. So there we see our guys typically said, oh, what's medium or low? They would see more as an informational thing, say, well, yes, maybe not that necessary to do, but it was good to see that high and critical, the tools seem to be really good to detect these things. So they seem to do a good job. Then you could say, well, open source, it's a good thing, but there are a lot of commercial products there on the market. What about this? And lots of the scanners are either respected community, like OWASP. This is there for a long time, it's well supported. Stuff like Trivi, Gripe, other scanners are actually from commercial companies. They use it in their commercial products where they have fancy user interfaces as well, but have their base scanners open source. So this is then the same basically what you get what they use for their products. And it can often be introduced faster. We see it in our project when I come to a customer and say we should do this, and then yeah, I need a vendor selection. These are quite expensive. You can say $50 to $100 per user per month. It's quite a lot of money. Then it's a lengthy process. You can start with this and do it quite easily, maybe for a small project or a larger project, or in your department. You could just start with it without procurement, vendor selection, all this stuff. On the other hand, commercial products have their strengths, so the support for developers fix the vulnerabilities are often better. They then have to list really how things develop in the source code, how variable is used and where it started and where it has been used. So they're quite good in this, what you don't get. They have strong user interfaces often, because then they have lots of developers behind them. I think SecObserve and Defect Dojo and Dependency Track have good user interfaces. They can do often more, to say it. And I think AI might give commercial products advantage in the future in identifying vulnerabilities. What is a vulnerability, to get even better there, and I know they're working on it. Companies like SNCC or so, to generate pull requests that fixes them when you trust AI. I I think you will always still have to look at it. But this might change because I would not expect this in the open source world in the future. So both, there are good products out there, but there are some, you can use open source approach as well, and it has its own advantages. So I would say go for it. We have made very good experiences in our company. As the summary, I think I have 10 minutes or so. Yeah, these are the 5 steps. Avoid vulnerabilities, do things not to have vulnerabilities in the first place. Use some well-known good vulnerability scanners. Use ready-made templates to make it easier for you. Import it into SecObserve or Defect Dojo. And then start working on this. You have transparency, you can do an assessment, and then you can start eliminate. And when you do these 5 things, you will have much more secure project and make it a safer and a more secure world. And that's what this conference is about. Thank you very much for your attention, and I think we might have time for a few questions then. There's one here in the front.
Thank you, Stefan. So, how can AI help for this process? What do you believe?
Wait, can help?
How can AI help for vulnerability management?
Yeah, I think maybe really in detecting things to support, say, the reading of the source code to maybe better detect things and have less false positives, and maybe interpret the context of a vulnerability in the source code. And then really, and I know SNCC and I think SemGrep are working on this to what a GitHub Copilot can do for you already, to say, I have a problem, fix it, or write me some source code, and then just generate the pull request. I think like this for the SQL injection should be quite easy for an AI system to generate then the other versions of an SQL that does not have this injection.
If I may ask another question, if you have 10 teams, how do you distribute the topics to the different teams?
Well, you would separate, so you have these products, you would have several products, so we have a large team for a customer, there are several sub-teams, and you can use product and product groups. So you have a product where you say, this observation belongs to this product, and you can have a product per team, or they have even further down because they say every one of their microservices as a product, and then they have a team which is responsible for certain products, and then you use a product group, and you can say, you can have a group of users or single users, you can say they are allowed to see this product or this allowed to see this product, and then you can separate it.
Thank you.
Hello?
Yeah.
My question is related to the same context. Can AI help to figure out the false negative instead of false positive? And how it can improve to figure out the zero-day vulnerabilities?
I'm not sure I got the second part.
The zero-day vulnerabilities.
Yeah.
Is there zero-day? Yeah.
The AI, you mean?
I mean, zero-day vulnerabilities.
0 day, yeah. This is always depends on the scanner, how good they are, how fast they are to have things in their rule set, or if there's a CVE on GitHub. So typically these scanners don't detect, like in your libraries, they don't detect 0-day vulnerabilities. They don't do source code analysis. They just say there's a CVE or on GitHub or in any other source, there is something. They detect it. The open source scanners will need that time until there's an official entry somewhere of the vulnerability.
Okay, but what about the false negative? If my scanner doesn't able to find out some kind of the vulnerabilities, which is hidden still, will the AI will help? Say for an example, I just did a scan with a tool and somehow it is not able to figure out some vulnerabilities.
Might help the AI, I'm not really sure. I'm not very deep into this area, how AI could really help there.
Okay, no issue.
Sorry.
All right, any more questions? Oh, sorry.
Thank you very much for the presentation of your product. It's a really interesting product for me. I have a few questions regarding which vulnerability scanners I'm able to connect to your software. Because you listed Azure Defender for Cloud as a source that you found to be reliable and good working. So what is reliable and good working? And am I right to assume that you mean working good with, how is it called? SecObserve? Because I was wondering why you did not list things like Security Command Center from Google as well. And is SecObserve able to parse information from the Google Command Center?
I don't have, we don't do a lot with Google in our company. Most customers use Amazon and Microsoft, so I don't have any experiences with Google. That's the reason why it's not on the list, lack of experience with it. Writing a parser is very quick. If there's demand, you could write your own parser. We had, so for example, this Trivi and Prometheus, this will be a contribution from someone. I won't write it myself or our team. And so writing a parser is quite an easy thing to integrate stuff.
Okay, thank you. May I ask another question? It's a really short one. You talked about rules for excluding false positive findings or changing the criticality of a finding. So am I right to assume that these rules are only done by knowing the syntax of writing those rules, and you not yet have something like a nice interface or something like that? And I know if I buy a software like that or use a software like that, I should know the syntax, but
it's not a syntax actually. It's a form where you write things, so you can just, it's pretty basic, to be honest. You can say you have regex for different fields of a observation, and there you can, with a regex, say if it fits the regex, then the new status or new severity will be applied. So it's in a form where you just have several fields. So that's
okay.
It's still basic, but easy to use.
Okay, thank you very much.
All right, all right. Thanks again. If you have additional questions, feel free to approach him anytime. And thanks again, Stefan, for your contribution.
Thank you.